Okay. So this experiment is spectrometer grating. The main aim of this experiment is determination of wavelength of mercury spectrum. Wavelength of mercury spectrum using a spectrometer grating. Okay. So this is the today experiment now. Okay. What's the aim of this experiment? To determine the wavelength of the mercury spectrum by using spectrometer grating. Okay, spectrometer grating. So this box is the lamp, sodium or mercury lamp. Okay, so this is the spectrometer. Spectrometer. You see this slide. So this is the spectrometer. So the spectrometer, first one is design of the instrument. Okay, so spectrometer consists of collimator. You see this collimator C. This one you see. Next one the telescope. See, so this is the telescope. So you see, so this is the grating or prism table. Okay, so you see, so this is the scale, linear scale. Okay, so you see, first one, the collimator is consist of a convex lens at one end. Students, are you hear my voice?
Yes, sir.
Okay, so this is the collimator consists of convex lens is fixed at one end. So this end, this convex lens is fixed, and another end is adjusted a slit. You see, slit. Okay, in the other end. So this is the collimator. Next one, the telescope. You see, so this is the telescope arrangement. So the telescope is consist of the object. So this one, the object. Next one is the eyepiece. Okay, other side is the eyepiece. Eyepiece is fixed with a cross wire on the other end. Okay, so this side. Next one is the table. You see, another one easily to understand. So this is the table. Okay, prism or grating table. Okay, so in this table is consist of two circular disc connected with the three leveling screws. So in this leveling screws. Okay, so this one is the table lock screw. Okay, so to release this screw, to move this table in up and down. Okay, up and down using this table lock screw. Okay, so this is the table. So this is the prism or grating. Okay, so you see, so this is the vernier scale reading. Okay, to note the vernier A and other side is vernier B. Okay, students, so this is the initial adjustments. So what is the aim of this experiment? Okay, so determination of wavelength of mercury spectrum, wavelength of mercury spectrum using spectrometer grating. So you know that what is wavelength. So in this experiment, the aim is determination of wavelength of mercury spectrum. So in this mercury spectrum, so roughly seven colors. Okay, in this violet to red to calculate violet wavelength of color predominant lines. Okay, violet to red wavelength 4000 Armstrong unit to 7000 Armstrong unit, and the red is a high wavelength. Okay, 7000 Armstrong to calculate each and every predominant lines. Okay, so wavelength of mercury spectrum. What is wavelength now? If anyone tell me in Tamil, alai neelam அப்படின்னு சொல்றோம். What is wavelength? As you see this diagram, you should understand what is wavelength.
The
Anyone?
distance between one crest to another, sir.
Yes, tell me, Amni.
The distance between one crest to another.
Tough. Uh, yes, very good, Yamini, very good. So the wavelength is defined as the distance between, you see, So this is the wavelength, the distance between crust and trough. Okay, very good, Yamini. So it's called the wavelength. Okay, ஒரு அகடுக்கும் முகடுகளுக்கும் இடைப்பட்ட தொலைவு அப்படின்னு தமிழ் சொல்லுவோம். ஸோ அலை நீளம் அப்படின்னு நம்ம சொல்றோம். ஸோ யூ சி திஸ் slide easily to understand. So this is the wavelength lambda. Okay, wavelength lambda. Okay, students, do you understand?
Yes, sir.
Yes. Okay. So this is the grating. So this is the source. Okay, light source, and this is the collimator. So this is the grating. Okay. So this is the first order. This side is left side. So this right side. So this is the first order springes, colors. First order. Same left side and right side. Next one colors. So the first order fringes totally 7 colors. Sometime 8 colors, some blue or some blue yellowish color, some different colors. So this is the first order spectrum. Okay, all colors are present in the first order, both left side and right side. Next is you see the telescope to move the left side. Again, the second order spectrum. We see the second order spectrum. Okay, it's the same both left side and right side. You see the next slide easily to understand. So you see, so this is the white light is passed through the grating. So diffracted images. So you see this. So this is the first order fringes. So violet color to red color. Again to move one side, again to move this telescope. Again the second order fringes is the same 7 colors or some 8 colors to see the colors second order. Same both side, left side and right side. Okay. So what is diffraction? So in this one light, white light is passed through this grating. Okay, so these diffracted images, lines, predominant lines, violet to red color. You see these colors, left side and the right side. What is diffraction? Yes. So the diffraction of light is defined as the bending of light around the corners, around these corners, bending of light around the corners. Okay, that it's spread out and illuminated areas. Okay, area shadow is expected. So these colors. Okay. You see next one. So this is the reading. How to take the readings? Okay. Once the cross wire is fixed to one predominant color, violet color. Okay. Then you take the readings simultaneously. You take the readings vernier A and vernier B readings. Okay. First one, if zero of the vernier scale is exactly coincide with the any of the main scale, that is the main scale reading. Okay, you note it each line. You see, so this is the main scale. Main scale is each line is equal to half degree. Each line is equal to half degree. So you see this one small line. One line is equal to half degree. Next one line is half degree, 1 degree. Next one 1 degree 30 minutes. Okay, 1 degree is equal to 60 minutes. 60 minutes, you know very well. I already studied in the 12th standard. Okay, 1 degree is equal to 60 minutes. Okay, to note the readings, for example, so this reading is equal to if anyone tell me what is the reading in this. If so, this is the zero of the scale. Okay, what is the reading? Zero of the vernier scale is exactly coincide with the any of the main scale. That is the main scale reading. So each line is equal to half degree. 110 degree 30 minutes is the main scale reading. Okay, students, to understand. So this is the 110. Next, so this each line is equal to half degree. 110 degree 30 minutes. Half degree means 30. 1 degree is equal to 60 minutes. So this one half a degree for 30 minutes. Main scale reading 110 degree 30 minutes. Then to calculate the Vernier scale coincidence. Okay, so the distance between 110 to 110 degree 30 minutes, this difference is equal to half 30 minutes. So this is the 30 minutes. Okay, if any one of the line, the 30 lines, is exactly coincide with the any of the main scale, that is the Vernier scale coincidence to note. Okay, to note. In the virtual class, I will explain clearly. Okay, so each and every student should note the readings when you're A and when you're B readings. Okay, so this is the scale. Okay, next you see, so this is the table. So this is the color spectral lines: violet to red, violet, blue, green, yellow. Sometimes yellow one, yellow two. Okay, red. Okay, totally seven or six or eight colors. So first one, left side or right side. You take readings as you wish. You take right side reading or left side reading. First to take the readings is one side. You choose left side means to take all readings left side. Then to complete this left side, then move to the right side. Okay, so this is the left side, so this is the right side. So in the left side, you take the note the readings in the vernier A and vernier B simultaneously to note vernier A readings and vernier B readings. So main scale reading, vernier scale coincidence. The same vernier B, same main scale reading, vernier scale coincidence to note the both vernier A and vernier B readings. Then move to another color. Okay, blue color, green, yellow, yellow to red. Okay, to note all the colors. Then move to right side. The same procedure is repeated in vernier A and vernier B. Okay, students. Then move to the virtual lab. Students, you see this one diffraction grating.
Yes, sir.
Yeah. So first one initial adjustment. Okay, first one before take the readings. First the initial adjustment is very important. I will explain one by one. You note it. Okay. So first one focusing of telescope. Okay. First one the distant object method. Okay. So you see this picture. Okay. So on leave to focus on tree leaves, right? So this blood, right, mom? So this image, you see this image. So this image is clear, mom?
Yes, sir.
Clear or blurred?
Clear, sir. Yes, sir.
So to using this focusing of the telescope, the image is you see this clear image. You see, yes, ma'am. You see the clear image.
Yeah. Yes,
Yes,
sir.
using the telescope is focused a long object. If any tree or any leaves, right? to adjust the telescope screw, okay, to see in the clear image. Okay, students, are you clear?
Yes, sir.
Yes, so this a clear, well-defined inverted image, okay, of a distant object is seen by adjusting the telescope. So this is the one distant object method. So this is the initial adjustment. Okay, okay, students.
Yes, sir.
So this is the second one. First one, initially the eyepiece adjustment in the uh, telescope, right? So the eyepiece is adjusted until the cross wire are clearly seen and viewed through the telescope. Okay. Then second one is the distant object method. You see one object, long distance object, focusing a telescope using any this image is blurred means using the screw to adjust the screw. Okay, to see the clear image. Okay, so this is another one, initial adjustment. Next is slit adjustment. You see this side. So this is the telescope. So this is the collimator. Okay, so in this collimator, so this side is slit. So this slit. So the slit is made narrow with the help of the screw. So using the screw, okay, provided a side of the slit. Okay, to adjust the distance between this slit. Okay, so, for example, it's a collimator. So, the telescope is brought online. You see this telescope, the this side is light image. You see in the light in the broadened image means using the screw to adjust. The slit is illuminated by the source of light. So, if the image of the slit is appears sometime is blurred means so the screw of the collimator is adjusted until the clear image is seen and viewed through the telescope. Okay, okay, students, are you clear?
Yes, sir.
Yes. So now the ray of light emerging. So this is the source. The ray of light is emerging from the collimator. Will be the random parallel image. Okay. Next, another one adjustment is the prism table or grating table. Grating table. Okay, so using the spirit level is placed on the table. If any one side, so this side or this side, using 3 to 4 places you fixed in this top of this table. Okay, using you see, so this is the screw, adjusting the screw. Okay, so you, students, you see the spirit level now. ரசமட்டம் தமிழ் சொல்லுவோம், பார்த்துருக்கீங்களா? ஸ்பிரிட் லெவல்.
Yes, sir.
Yes, so air bubbles in the spirit level is brought to the center of center by adjusting the two screw using the screw. So it's then placed in the perpendicular direction, and the bubbles is brought at the center by adjusting these two screw. Okay, two screw. So these bubbles to move in the center of the spirit level. Okay. Now the prism table or what grating table will be horizontal. Okay, horizontal. So this is the initial adjustment. Okay, students. First one, eyepiece adjustment. The eyepiece is adjusted until the cross wire are clearly seen and view the uh, through the telescope. The second one is the distant object method. Okay. Third one is the slit adjustment. Then fourth is the this collimator adjustment. Next the prism table adjustment. So this is the initial adjustment. Okay, students. So in this, before doing any experiment using the spectrometer, so the above mentioned initial adjustments have to be made. Okay, students, are you clear?
Yes, sir.
Yes, so you see, so this is a vernier scale, one side vernier A or vernier scale 1. So other side you see, this is a vernier scale 2. One side 1, another side is 2. Okay. Next to start the experiment. To start. So you see, so this is the vernier scale 1. So this is the vernier scale 2. Okay, ma? Students, you see clear, no?
Yes.
This
Yes, sir.
image. Okay. Next one, the adjustment of grating for normal incidence. Normal incidence. So the these preliminary adjustments, initial adjustments of the spectrometer are made. First one, you see. So this is the enlarged image amount. So this is the vernier 1. So this is the enlarged image. Okay. So this is the vernier table 2 or vernier B. So this is the enlarged image. Okay. So this is the spectrometer. So this is the what? Telescope arrangement. So this side is the collimator arrangement. Okay, so this is the slit. So this is the source, light source, light source. Okay, first one, you noted the initial adjustments of the spectrometer. Okay, next one, the grating is mounted on the grating table. So so this is the table. Okay, so the grating is mounted on the grating table. Okay, with its ruled surface facing the collimator. Okay, so this is the table. You see, so this is the grating is fixed. Okay, so this slit is illuminated by the light source. You see, switch on the light. So this is the light source. Switch on the light. Okay, switch on the light. You see, ma? Clear?
Yes, sir.
So you see, switch off the light. Next, you remove the grating to remove the grating. Okay. Again, to place the grating, then to switch on the light. Okay. Are you clear?
Yes, sir.
Yes. Next one, you see, the grating is fixed. Okay, in the table, and light is switched on. Okay, so this next one, one side vernier scale, you see, zero of the vernier scale is exactly coincide with the zero of the main scale. Another side is zero of the main scale is exactly coincide with the 180 degree. So the difference is 180 degree. Read 0 degree and 180 degree. Okay, so the vernier scale are adjusted. Vernier scale are adjusted 0, 180. One side is 0, another side is 180. Okay, if any changes, you see this vernier, if any changes means to adjust these lines, adjust. Okay, if, you see the telescope is readings is 0, to move on other side means to adjust the lines. You see, to move again to fix 0 of the vernier scale is exactly coincide with the 0 of the main scale. You see, to adjust. Yes, adjust. You see the light now. The white light is exactly coincide with the center of the cross wire. You see 0 to 180 fixed. One side is 0 to 0 of the inner scale is exactly coincide with the 0 of the main scale. Another side is 180 degree is coincide. Okay, to adjust. At the same time, you see the white light or sodium lamp, using sodium lamp light is exactly coincide with the center of the crosswire. Okay, you see this, your eye. Okay, you see, so this white light is exactly coincide with the center of the crosswire. Okay, yeah, students, you see, ma? Exactly, if 0 of the vernier scale is exactly coincide with the 0 of the main scale, another side is 0, 180. So the difference is 180 degree. You note it. So this is the direct ray. You see this light, white light is exactly coincide with the center of the crosswire. Okay, so this grating table is suggested until the image coincides with the vertical crosswire. Okay, so both the grating table and the telescope is fixed at this position. Okay, students, are you clear? Students,
Yes, sir.
yes.
Yes,
Any
sir.
doubt, ma, in this part? So
No,
vernier
sir.
scale are adjusted to read 0 and 180 for the direct ray. The telescope is rotated through an angle. Next one. Okay, ma. So this is clear. Next, you see. So this is the telescope to move in the right side, 90 degree. Okay. So these vernier scales are first one is over. Next one, the telescope is rotated through an angle 90 degree and is fixed. Okay, one side, any one side. Okay, right side or left side. Now they move in the one side, right side. So this telescope to move 90 degree and is fixed. Okay, you see. So this is the telescope. Yeah, students, clear ma? 0, 180. Okay. 0 of the Vernier scale is exactly coincide with one side 90 degree, and 0 of the Vernier scale is exactly coincide with this 270 degree. So this difference is 180 ma. You note it, 270 degree one side, another side is 90 degree. 270 minus 90, how much ma? Yes, 270 minus 90. Students?
180, sir.
Yes, so this difference is any time. So this two table reading difference is 180 degree. 180 degree. So this telescope is adjusted. Okay, telescope is rotated. Adjust rotated through an angle 90 degree. One side 90 degree, another side 270 degree. Okay, so total difference is 180 degree. You concentrate only one side. So to adjust the 0 to 90 means another side automatically the reading is 0 to 70. Okay, so are you clear?
Yes, sir.
Then they fix the telescope. Okay, so the telescope is fixed, don't move. So 90 degree is fixed, to fixed, right? Then, so the grating table, you see the grating table. Students, the grating table is adjusted until the image is coincide with the vertical crosswire. Okay, the grating table is adjusted until the image coincide. You see this side, the telescope. Okay, you see the telescope and to move the vernier scale. So the table, vernier table. Okay, until the image is coincide with the vertical crosswire, you see these white lines in this crosswire is coincide. Okay, you see. So the uh, creating table to adjust. Yes, students, you see creating table to adjust it. Okay, until the image coincide with the vertical crosswire. Right, like you see the telescope. Okay, automatically you then you move the table, grating table. Okay, so this light is coincide with the center of the crosswire. Okay, slightly to move the table. slightly move. Students, so this light is exactly coincide with the center of the crosswire. Okay, students, are you clear? Students, you see this
Yes,
white
sir.
light is exactly coincide with the center of the crosswire. So both the grating table and the telescope is fixed at this position. Okay, ma?
Okay, sir.
Okay, question. Then next, now they rotate the vernier table through 45-degree in the same direction in which the telescope has been previously rotated. Okay, yes. So to move 45-degree, okay, vernier table to rotate a 45-degree in the same direction in the telescope has been previously rotated. Okay. Don't move the table, grating table to rotate the vernier table. Okay, see. Yeah. So you see 0 to 90 and to move 45-degree. Ninety plus 45 how much more? 90 plus 45, 135.
5, sir.
To fix 135 more. 45-degree to move. Okay, 45-degree. Yes. Yes, 135-degree. So you see this table grating to fix in the same position. Okay. Next, to release this telescope. Okay. So the telescope is released and brought on the lines and the direct image in the grating. You see, to rotate the traveling microscope into right side to left side. So this side. So you see this white light is exactly coincide with the center of the crosshair. It's the direct ray mark. Okay. So this is the direct ray. So you see this collimator and telescope is the straight line. Okay. So this is the white line is exactly coincide with the center of the cross wire. Okay. So this position is called the normalized incidence position. Okay. Students, you note it. Now the grating is said to be in the normal incidence position. Okay. So this is the direct ray. Direct ray. Okay. Then the telescope move to left side and the telescope move to right side. Okay. You see the different colors, predominant lines, violet to red color, right side and left side. Okay. Students, are you clear? Students,
Yes, sir.
yes. Next one is the determination of wavelength of mercury spectrum. Mercury spectrum. So the diffracted images of the first order fringes you seen on either side of the center direct image. So this is the direct image. Next is the telescope to move in the left side. To take the readings, first violet to red. To fix one color, first violet color. To fix the cross wire. Then to take the readings linear A and linear 1 and linear 2. Okay. Then the telescope to move. Again to fix the another one color, you take the readings. Okay. So first to one side to move and to fix the colors and to take the readings. Okay. Students, are you ready to take the readings?
Yes, sir.
Okay. Left side or right side, ma? The telescope? Any one side you take the readings. Left side or right side?
Right side, sir.
Right side you take the readings. Okay, you see. So the telescope move right side. You see, this is the white light, slightly move. Next, these colors. You see the predominant colors. Okay, namely violet, blue, bluish, sometime bluish green, green, yellow color, and red of the mercury spectrum. Okay, first one, which color, ma? Friends, you see the colors, ma? First
Yes,
color,
sir. Visible.
you see. You see, this is the first order spectrum. Okay, so first order you see violet to red color. Okay, violet to red color. Next, you see the next one. So this is the second order spectrum. You take the readings only in the first order spectrum. Okay, so this is the second order. Next, you see again to move the telescope. Next, third order, fourth order. Okay, you see. So this is the first order. So this is the white light. Next to move the light. Okay. Again to move the telescope, the right side. To fix first color. First color, color ma. First one. First color you see. Color.
Blue, sir.
Yes, blue. To fix the blue color ma. Okay. So exactly the blue color is exactly coincide with the cross wire. So slightly slowly to move the telescope correctly to exactly to fix the blue color in the center of the cross wire. Okay, we'll see. Okay, okay. So this exactly coincide. So this blue color is exactly fixed in the center of the cross wire. Okay, you take the readings first. So this is the vernier A reading. Next vernier B readings. Okay. So if anyone tell me, so this is first reading. So this is the vernier A or vernier 1. So the second one vernier B or vernier 2. You take the readings, blue color, right side. Right side, you take the readings, main scale reading and vernier scale coincidence. Yes, if anyone tell me, one side vernier A, if zero of the vernier scale, you see ma, so this is the zero of the vernier scale, you see, so this is the zero of the vernier scale is exactly coincide with the any of the main scale, that is the main scale reading. Okay, you see each line is the half degree, 30 minutes, you know already uh, explained, 1 degree is equal to 60 minutes. So each line, you see, so this is the main scale. Main scale, each line is equal to half degree. Half degree is equal to 30 minutes. Okay, 30 minutes. You see, zero of the vernier scale is exactly coincide with the any of the main scale. That is the main scale reading. If anyone tell me, each line, small line is equal to half degree. So you see, so this is the 60 degree, 60 degree 30 minutes, half degree 61 degree, 61 degree 30 minutes. Next in the big line is the 1 degree, small line is the half degree. Okay, yeah, tell me, students, tell me the readings form. When you're A reading, students, zero of the vernier scale is exactly coincide. Tell me the readings. Is it 50, 5, 6,
58, sir.
7, 8? Yes. Big line is 1 degree ma, is half degree ma. 59 degree ma.
59, sir.
59 degree. Okay. So this is the main scale reading, 59 degree. Okay, 59 degree. You note it, 59 degree. Students, you note your observation note. Okay, so determination of wavelength of the predominant line of the mercury spectrum. Color of the spectral lines is violet. Okay, only one violet color. Okay, so this main right side, main scale reading, vernier A reading, how much more? 59 degree. 59 degree, you note it, 59 degree. Then you to note the Venus scale reading or Venus scale coincidence. If any one of the line, you see this Venus scale is 30 lines, 0 to 30. If any one of the line is exactly coincide with the any of the main scale, that is the Venus scale coincidence. Okay, you see, students, easily to note the Venus scale coincidence. You see, one line to another line difference is equal to how much more?
Half degree, sir.
Half degree, 30 minutes. 30 minutes. That's 30 minutes, 0 to 30. So you see, you imagine the big line is your house. Another one small line is college. So the difference is equal to 30 kilometer, for example. Okay. The 0 is the uh, bus. Okay. So already explained in Young's models experiment. Okay. So this difference is equal to 30. Okay, so this zero of the Venner scale is coincide the nearly 59 degree. Okay, above this 59. So this coincidence is below 5. So this only this difference. So is zero of the Venner scale is coincide with the middle of this line means how much more? 15. Coincidence 15. Above middle 16, 17, 18, 20, 25, 26, 28, next is 30. To note, the 30 means again this line move to another line. Okay, another line. So in this, you note it, if we, which line is coincide. Ma? You see the 30 lines, which line is exactly coincide. So you see the second line, no? Vernier scale line is exactly coincide with the main scale. Any of the main scale. You see all the lines, only one line, the second line is exactly coincide. So Venn scale coincidence is equal to 2. Okay, students, you note it. 59-degree main scale reading, Venice scale coincidence, 2 minutes. Okay, 2 minutes. Okay, total reading 59-degree, 2 minutes. You note it. 59-degree, 2 minutes. Next ma, that is same. You note the second vernier 2. If anyone tell me the readings, students, if zero of the vernier scale is exactly coincide with the any of the main scale. Yes, Yamini.
149.
Yes, tell me. One.
149, sir.
No, you see, 148-degree 30 minutes. You see, if zero of the unit scale, you see ma, 148-degree 30 minutes. Okay, not cross this line 49. Okay, to cross only in the 148-degree 30 minutes. So this zero of the Venus scale is coincide with the middle of this line, 148-degree 30 minutes to 149-degree. Okay, so this main scale reading is equal to 148-degree 30 minutes is the main scale reading. Okay, tell me more readings. 148-degree 30 minutes. To note the Venus scale coincidence, you note more. If any one of the line is exactly coincide with the any of the main scale, note.
Sixth line, sir.
Yes, tell me more. If any one of the line ma 0 to 30, if any one of the line is exactly coincide with the any of the main scale, you see the first line, second, third, middle na 15 above middle. You see the 15th line is exactly coincide with the any of the so this main scale, that is 15 is the Venus scale coincidence. Okay, 50 minutes. So to note the total reading, tell me ma, main scale reading 148-degree 30 minutes, Venus scale coincidence 15 minutes. So total reading 148-degree to add 30 minutes plus 15 minutes. 148-degree 30 plus 15,
45, sir.
45 minutes. Okay ma, 45 minutes. Okay, friends, are you clear? To note the Venus scale A and Venus B readings, main scale and Venus scale coincidence. So this one reading over now. Okay, students, are you clear? To note the readings. First Venus A reading 59-degree 2 minutes. Venus B 148-degree 30 minutes main scale reading. Venus scale reading 15 minutes. You note it. Then move to the next color. Next color, which color mom?
Violet, sir.
Yes, violet 2. Right now?
Yes, sir.
Violet 2. To move. Next color. Violet 2. So exactly the violet 2 color is exactly coincide with the center of the crosswire, using slightly to move the telescope in the right side. Okay, exactly to fix this color, violet 2 color is exactly coincide with the center of the crosswire. Okay, okay, you take the readings. Students, one by one you tell the answer. Take you see the vernier A table. Tell me the readings.
60
Violet
degrees,
blue.
sir.
Yes? Yeah, very good. Alright. Students, very good, ma. 60 degree. Vernier A 60 degree. To note the main vernier scale coincidence, ma. So this 0 of the vernier scale is nearby this 60, means below 5 or below 10. Only this vernier scale coincidence. So second line, you see the second line is exactly coincide. Okay, you see, so this second line is exactly coincide with any of the main scale. Why is our second scale, second line is exactly coincide? So this 0 of the vernier scale is coincide with the nearer to the 60 degree. That's why this coincidence is 2. Okay, students, are you clear? You see, is exactly coincide, but 2 is the coincidence. 2 minutes. Okay, next one to note, to tell these readings, vernier B or vernier 2 readings.
49, sir. 149.
Oh, very good, ma. 149 degree. Very good. 149 degree, 30 minutes, ama. See, the big line on the 149, ma. The small line on the half degree. 149 degree, 30 minutes. Correct, ma?
Yes, sir.
Yes. To note the vernier scale coincidence. So this 0, you see this 0 of the vernier scale is nearer to the 150 mark. Okay, 150. So I'll expect this vernier scale coincidence is below, above 25. Above 25. You see this 28th line now. 28th line is exactly coincide with the any of the main scale. But 28 minutes is the vernier scale coincidence. 28 minutes. Students, are you clear, ma? So first one, vernier A total reading, tell me 60 degree 2 minutes. 60 degree 2 minutes. To note vernier B reading, ma total reading 149 degree,
30
30
minutes,
plus,
sir.
30 plus 28, ma.
58.
Very good. 58 minutes. 149 degree 58 minutes. Okay. Then move to next color. Next color, and which color, ma? Next color.
Light blue, sir. Sky blue.
Sky blue. Okay, yes. To slightly, the telescope is likely to move in the right side. Again, to fix this blue color. Okay, to fix the telescope in this color. Okay, so this exactly this blue color is exactly coincide with the center of the cross wire. Again, to take the readings. Okay, yes, blue color. Again, to take the readings. Tell me, mom.
65, sir.
Yeah, very good. 60, not more, 65. So you see, so this
63,
is
sir.
65. So this is the 65. This is this one,
63, sir.
63, not 63. So this is the 63. So the 63 is the 62.
62, sir.
62 degree, very good. 62, the 63, the 64, the 65. The 62 degree, ma, very good. 62. Blue color, 62 degree. 62 degree is the main scale reading. Next, to note the vernier scale coincidence. Same second line is coincide. Okay, you see the second line is coincide for 2 minutes. So total reading 62 degree to
20 minutes, sir.
2 minutes. Very good. 2 minutes. Okay. Next to note the Vernier B readings, Vernier 2 readings, right? Yes, tell me. So this is the 150, 151, 152. So this 152, this 151. Tell me.
151 30 minutes, sir.
Yeah, 151, 30 minutes. Okay, very good, ma. 151 degree 30 minutes is the main scale reading. Coincidence, you see the middle is null, above middle. You see, I will expect 19, 20 or 25. So you see 18th line,
19th,
the
18th line.
18th line, you see. So this exactly coincide. So 18 is the Vernier scale coincidence, you see 18. So total reading, ma?
151 48 minutes, sir.
Yeah, very good. 151 degree, 48.
48
Very good.
minutes.
48. 48. Who is answered or who is exactly to note the readings means I will note your name. Okay, I will give the full mark in your experiment. Right, ma?
Yes, sir.
So all are recorded.
Okay, sir.
Okay, all students to sorry, you note the readings. Each one students you note Vernier A, another one student to note Vernier B readings. Then next students to note another one color Vernier A and Vernier B readings. Okay, each and every student name noted. Okay, then finally I will give the full mark. Okay.
Sir.
Okay, students. So then next the same process is repeated. So the Vernier scale is exact next to move the right side again. Next color,
Green, sir.
Green,
green
sir.
color. Very good. Green color. Again the telescope is moved in the right side slightly to move. Again to fix this green color exactly coincide in the center of the crosswire to note. Yes. Yes, ma'am. You note it, ma'am. If anyone tell me when you
64,
A
sir.
readings 60,
4.
yeah, 64, 60, very good, 64 degree. Okay, 64 degree is the main scale reading. When is scale coincidence, ma?
Same
2 minutes,
second,
sir.
sir.
Same.
Second line.
Yeah, very good, very good. Second line, very good, ma. 64 degree, 2 minutes, ma. 64 degree main total reading. 64 degree, 2 minutes. Next, you note the Vernier scale. Two Vernier B.
158, sir.
Not more
158
158,
30 minutes, sir.
150,
152, sir.
153,
3
153,
30 minutes, sir.
30 minutes. Correct, no?
Yes, sir.
153, 153 degree, 30 minutes is the main scale reading. 153, 30 minutes. Coincidence, no? Above middle. Yes, tell me. You see this line is exactly coincide. Which line, ma? This line.
16, sir.
Yes.
16, sir.
16.
Feeling ma number 16 now.
Yes, sir. 16.
2, 3, 4, 5, 16. 16th is the coincidence, any skill coincidence. 16th line is exactly coincide. For 16, tell me the total reading now.
153 degree 46 minutes, sir.
Yeah, 46 minutes. Very good. Okay, ma, students, clear, ma? If any doubt,
No, sir.
okay.
No,
Then,
sir.
next, ma, next
Yellow
Yellow
color,
color.
color.
yellow. Again, the same process is repeated. Again, the telescope slightly to move in the right side. Again, to fix the yellow color is exactly coincide with the uh, center of the cross wire. Again, you take the readings. Okay. Okay, you tell me. Readings. Yellow color.
5
65.30.
degrees, sir.
Yes, yeah. 65 degree. Very good. 65 degrees is the main scale reading.
3 minutes.
Yeah, three.
Third
Three or
line,
four
sir.
ma? One, two, three, four. Ah,
Yes, sir.
four. Right, ma? Four. Total reading, ma? 65 degree,
65 degrees, 4 minutes, sir.
4 minutes. Very good. 4 minutes. Same procedure. Vernier B readings. Vernier B.
155, sir.
155, sir.
150.
5.
No. You see. Not exactly coincide with 155.
154, 13
Yeah,
minutes, sir.
very good, very good. 154 degree 30 minutes. Very good, ma. 154 degree 30 minutes is the main scale reading. You see, the zero of the Vernier scale is exactly coincident with the nearby this 155. So you see, 40 the 28 or 29th line is coincide. You see,
8th line
29th line.
also, sir.
Tell me.
29, sir.
Yeah, very good. You see, the 29th line is exactly coincide. But 29 is a Venuscal coincidence. The total reading, no?
154, 59 minutes, sir.
59 minutes. Okay, very good. Okay. Next, telescope slightly to move in the right side. Again, color mount. Red color not visible. You see? So this is the second order fringe again to see. So in the first order, you see, ma? Any red color
No, sir, not visible.
not visible. Okay, so no problem. So this is the first order fringes now. So this first one, what color? Violet one, violet two, and third color in bluish green, green, blue color, next green color, next yellow color, not visible in the red color. Okay, no problem. I take one, two, three, four, five readings. Okay, students, again to move this telescope in the right side. So this is the first order fringe. You see, next is the second order fringes. Okay, so this is a small n value now. Small n, you take the readings in the first order fringe, na, small n value is equal to 1. Okay, you note it. You take the readings in the second order as you wish. You take the no, I'm not you take not to take the readings in the first order. Sir, I take the readings in the second order means small n value is equal to what now? 2. Okay, 2. Small n is equal to 2. So this is the second order fringes. We see. So this is the second order fringes. Friends, you see. So this is the second order. Again, the telescope is again to move in the right side means next you see the third order fringes. Small n value is equal to order of the diffraction order is equal to 3. N is equal to 3. So this is second order over. Next you see the third order. Let's see. Only two order fringes only you seen. Okay, no problem. Students, are you clear? One side reading is over. Okay, then the telescope again to move in the left side. Direct reading. Direct reading. Direct reading, white color. Yes. So this is the center. Direct ray, the white light. Okay, students, are you clear? So this is the center now. So the right side reading is over. So this is the direct ray center. Again, the telescope moved to left side. Okay, left side. You see. So the telescope to move in the left side. To take the same process is repeated now. So you take first order fringes. First which color now? Color violet color.
Blue.
Yeah, violet or blue? Yeah, first one blue color.
Yes.
Blue or violet?
Blue, sir.
Violet color?
Second, sir.
Second violet. Where are they? First violet, next தான் color. Okay. Okay, note it now. First one blue. Okay. The blue color exactly coincides with the center of the crosswire. You take the readings. Yeah, tell me now. So blue color. Yes.
30 minutes, sir.
Yeah, very good. 30 minutes. Blue color. Blue color. When you're A, 30 minutes is the main scale reading. When you're scale coincidence now. N scale coincidence, you see this, so this line 10, 11, 12, 13, 14, 15, 16 now. Correct now? You see
Sir.
16th line is exactly coincide. About 16 is the N scale coincidence. Total reading now 30 degree 40,
46 minutes.
46 minutes. 46 minutes. Okay. Next. Next when it be
120, 30 minutes, sir.
okay, very good. 120 degree, 30 minutes is the main scale reading. Very good. Coincidence 1. You see, first line is exactly coincide. Coincidence is 1. Total reading now 120 degree,
120, 31 minutes, sir.
31 minutes. Okay, very good. Next, the telescope is again to move the left side. Don't take the readings in the violet color. First order line is violet ma. I'll to leave it, no problem. Next, third color ma. Third color,
Blue color, sir. Sky blue.
sky blue. Okay, sky blue. The sky blue is exactly coincide with the center of the cross where you take the readings. Okay. Yeah, tell me ma'am. Sky blue. Yeah, tell me.
27, 30 minutes, sir.
27, 30 minutes. Main reading. Coincidence.
60 minutes, sir.
And 6 yes, 6 minutes.
Yes, sir.
Coincidence total reading 27 degree 30
36 minutes.
36 minutes. Very good. Okay, next ma'am. Then you B 1 1 1
170,
117.
170, 30 minutes.
Yeah, 117 30 minutes. 117 degree 30 minutes. Coincidence
1 minute, sir.
1. Okay. Means total reading 117 degree
31
31
minutes.
31 minutes. Okay, very good. Okay, next color. Again, the telescope move in the left side. Again, color green, amma.
Yes, sir.
Green color. Okay. So the green color is exactly coincident with the center of the classifier. Again, you take the readings. Yeah, linear A and linear B readings. So green color, you note it. 20,
25, 30 minutes, sir.
25. Very good. 25 degree 30 minutes. That's the main scale reading. N scale coincidence 28. Okay. Correct now?
Yes, sir.
Yes. Total reading 25 degree 58
58.
minutes. Okay, very good. Next, very near B side. Ma. 1 150 now.
Yes, sir. 115, 30 minutes.
30 minutes main scale reading. Coincidence
3, sir.
3. Very good. 3. Total reading 115, 115 degree and 33 minutes. Ama.
Yes, sir.
33 minutes. Okay. Students note the readings now. Then the telescope again to move slightly to move in the left side. Again, which color? Yellow color. So the yellow color is exactly coincide with the center of the crosswire. Again, you take the readings vernier A and vernier B readings. Okay. Yes, students.
24, 30 minutes, sir.
Yeah, students. You hear my voice now? Some network.
Yes, sir.
Okay.
Yes, sir.
Yes. Yeah, tell me this Vernier B readings 114 degree.
30 limits, sir.
Ah, ஆமா.
Coincidence 29, sir.
Yeah, coincidence 114 degree only. இது main scale
Yes,
114.
sir.
Main scale, the Vernier scale coincidence
29.
not 29 ma 29 okay 29. So total reading
114, 29 limits, sir.
29 minutes. Okay. Okay, next again to move this color, again the telescope to move in the left side slightly to move. You see, not see this red color not seen, right? So next one again the second order fringes now. You see, so this is second order fringes. Okay, students, the reading is over both side, left side and right side. Then only in the calculation part now. Okay. So next one diffraction 2 theta to calculate, and then theta value to calculate. Okay. Then finally mean theta value to calculate. Then finally to substitute all these values, the theta value formula is lambda is equal to sine theta divided by capital N into small n. So sine into the mean theta value to substitute divided by capital N. Capital N is number of lines per meter. So your grating lines is 15,000. Okay, small n value is equal to first order fringes. N is equal to order of fringes. So you take the readings only in this order is first order fringes. Okay, to substitute all these values, so automatically to calculate this wavelength of predominant lines of mercury spectrum. Students, tell me your feedback. How is this experiment? Is it to understand or not? Tell me.
Understood, sir.
Understood. Very good. So
Understood, sir. Sir,
very
இதுல
good.
வந்து violet color எடுக்கலைங்க சார் நம்ம எடுக்கிறப்ப லாஸ்ட் இதுல
என்ன சரண்யா?
லாஸ்ட் இதுல violet கலருக்கு வந்துட்டு ரீடிங் எடுக்கல சார்.
அதுல வந்து சேஞ்ச் ஆகி வந்துருச்சுமா, அதனால அதை விட்டுட்டோம் நம்ம. அப்படி வரக்கூடாது.
ஓகே.
ஆர்டர் வந்து வயலட்டு, நெக்ஸ்ட் ப்ளூ, கிரீன், எல்லோ, ரெட்னா நெக்ஸ்ட் லெஃப்ட் சைடு ஆர் ரைட் சைடு போத் சைடு சேம் ஆர்டர்ல இருக்கும். சரிங்களா? இல்லைன்னா நம்ம விட்டுடலாம். சரிங்களா? இது வந்து ஒன்லி இந்த சாஃப்ட்வேர், அதனால ப்ராப்ளம் இருக்கு. நீங்க நேர்ல எடுத்தீங்க அப்படின்னா லேப்ல உங்களுக்கு ப்ராப்ளம் இருக்காது. சேம் ஆர்டர் அப்படியே இருக்கும். வயலட் டு ரெட் தாங்கம்மா இருக்கும். சரியா?
ஓகே சார்.
So in the next class, spectrometer prism experiment in the next class. Okay. So note the readings. Okay, you calculate the 2 theta value. You see, I will explain this 2 theta and theta finally to calculate a lambda value. Okay. Why only 40 students only present? Why 39 students only present today?
So most of them left in between the class itself. So
Okay, students, you note it, student's name, right?
yes, sir, noted, sir. Now who are all there? That only we noted, sir.
Okay, but I note the name. Wait.
Okay, sir.
Okay, note all the names, 39 students name. Okay, the students, if any doubt in the calculation part, you ask. Okay, tomorrow, Monday. Okay, Monday, Tuesday. Then the next Saturday, I will explain and the spectrometer prism experiment. Okay, ma? Students?
Yes, sir.
Yes, sir.
Okay. இதில் வேற என்ன டவுட் இருக்குங்களாம்மா
No, sir.
ஸ்டூடெண்ட்ஸ்?
No, sir.
Sir.
கொஞ்சம் ஈஸியாக